Welcome everyone. Our topic for this presentation is cloud-based config management tool, and my team members are me, Arden Kote, and Jay Malve. So this is our topic for the DSC project. So our project title is cloud-based config management tool. So basically, the main goal of this project was to simplify and centralize the management of critical development resources, such as environment variables, branding assets, and media files. By integrating modern technologies, we aim to address the common challenges that teams face, such as scattered configurations, lack of visibility, and inefficiencies in workflows. Our project, which is this tool, ensures that the development teams can work more efficiently, maintain consistency, and streamline the deployment process. Coming to our project goals, we have three type of project goals that we kept in mind before making this project. Those were namely environment variable management, brand kit management, and the media management. The cloud-based config management tool was designed with these three goals first in mind. First, we wanted to enable centralized configuration management. This allows development teams to manage all environment variables and settings in one secure location, reducing errors and improving collaboration. Secondly, we aim to provide graph-based visualization using Neo4j. This helps developers understand the relationship between configurations, making complex dependencies more manageable. For example, our teams can visualize how a variable is linked to specific projects or environments. Lastly, we focus on creating a user-friendly interface using the React and Next.js modules. This tool features real-time updates and role-based access control, ensuring that only the right people have access to the right configurations. By meeting these goals, our tool simplifies the workflows and boosts the productivity for development teams. So now moving to our software and hardware components. These were the software and hardware components that were listed on the PPT. To build this project, basically, we utilize a modern tech stack to ensure functionality, scalability, and performance. Our front end is built on React and Next.js, providing a dynamic and responsive user experience. The backend is developed with Node.js and Express.js, which handles API requests and business logic efficiently. Neo4j, which is a graph-based database, was chosen for its ability to quickly query and visualize relationships between data points. For our media storage, we use the Amazon S3 bucket, which provides secure and scalable storage with pre-signed URLs for uploads. Coming to the hardware side of our components, the project is hosted in the Google Cloud Run, which ensures scalability and automatically managing the required resources. The development was carried on machines that could run on 8 GB RAM and multi-core CPUs, ensuring smooth coding, testing, and debugging. Coming to our architectural diagram, the architecture of the cloud-based management tool integrates various components to create a seamless, scalable, and efficient system. The front end that was built on the React and Next.js communicates with the backend via secure API calls. The backend, powered by Node.js and Express.js, processes these requests and interacts with the Neo4j database, which stores and manages relationship between configurations, branding assets, and media files. The media uploads are handled by the AWS S3 bucket using pre-signed URLs, ensuring secure and efficient file transfers. Both the front end and the back end are deployed in the Google Cloud Console, which scales automatically based on the traffic. Monitoring and error tracking are managed by Sentry, allowing for real-time diagnostic and issue resolution. Our architecture ensures a robust, user-friendly, and future-ready tool for development teams. Slide, debugging and testing were essential to ensure that the tool's reliability and performance. On the front end, we use the Chrome developer tools and React dev tools to debug rendering issues and track the flow of state and props. React time updates and WebSocket connections were monitored using network tools. For the backend, we relied on logging with Winston and Node.js's built-in debugger to trace API calls and identify errors in the business logic. Database interactions were debugged using the Neo4j browser to test and optimize Cypher queries. Rigorous testing was performed at every level. Unit tests were implemented using Jest and Mocha, while integration tests were carried out with Postman and Cypress. Performance testing with JMeter ensured the system could handle high workloads. Finally, Sentry provided real-time error tracking, helping us resolve issues quickly and effectively. This is our entire system working, as explained in the architecture. Our tool was built to handle significant workloads, including managing large volumes of environment variables, branding assets, and media files. Our system supports multiple simultaneous users, leveraging the scalability of Google Cloud Platform to dynamically allocate resource based on demand. Another potential bottlenecks include complex Neo4j queries, high AWS S3 storage costs for large media, network latency in real-time updates. Our last two slides talk about the conclusion and future scope that could have been included in the project. In conclusion, the cloud-based config management tool successfully centralizes and simplifies configuration, branding, and media management for development teams. By leveraging this technology, the tool delivers a secure, user-friendly, and scalable solution. This project has been an invaluable learning experience, and we thank Professor Eric Keller for his support and guidance throughout the development process. Looking ahead at a future scope, the tool has significant potential for expansion. Future improvements include integrating AI for predictive analytics, supporting multi-cloud deployments, and refining the user interface further. These enhancements will ensure the tool continues to meet the evolving needs of development teams. Thank you. Now Jay will be showing the demo.
Uh, okay, so this is the React application. So we have sign in with clerk. So you can continue signing in with clerk. Okay, so yeah, I got signed in. Here, this is my profile. I can manage my account and everything. So there are three things, as Arden explained, three aspects of the project. First is managing config, second is managing brand, and third would be the media. So config by config management, primarily we mean that we can efficiently manage all the environment variables required for all the big systems. So if I just start and I can just do like next public, for example, API key sample, I just put the value, a random value to store, and if I hit on save, then the variable is added successfully. This variable goes in. So if I go to Aura Neo4j Aura, you can see the variable that we just added being added to the database. Uh, just a moment. Config, and here will be the key that we added. Optional field is a description. You can add a description, but by default it goes as null. Even here you can see you can toggle between sensitive and insensitive showcase of the key. Moving ahead to brand. So this is the brand kit. So every website has a brand, right? They have logo URLs, they have colors and font family, everything. So over here, what you can do is like, for example, I'll take this image as my logo. So like, let's suppose I am building a brand kit for Cash App. So this is how I get the previews. For just a moment. Yeah, complete media management of the entire system relies on Amazon S3 bucket. So I'll show you the flow. So if you choose a file, and if I choose a file and upload image, I can see image uploaded successfully. And if I just refresh uploaded media, so this is stored to S3 bucket. So if I just open the image, you can see it's on S3 EU North 1 AWS.com.